So this is a paper, recent paper, more on El Nino triggering mechanism. So I'm putting it here in new findings in climate change because this is relevant just in terms of how El Nino may respond or may have been responding already to global warming is anything but clear. All sorts of conclusions are made based on models, and this process still remains somewhat of a mystery as to exactly what triggers El Nino initiation. Even though forecasts are made, overall skill is fairly high, especially 2023 El Nino was predicted very early on, and so on and so forth. So this paper by Westerly and Carniel says where the winds clash, what is really triggering El Nino initiation. El Nino Southern Oscillation is Earth's strongest source of year-to-year climate variability, whose center of action, although being in the tropical Pacific, influences global climate, impacting also security aspects, and so is commonly described as an irregular oscillation of the coupled ocean atmosphere system, which produces an oscillation in the sea surface temperature between a warm and a cold phase, so El Nino and La Nina phases, induced by internal waves propagating along the equatorial waveguide and generated by the convergence between high-frequency westerlies, so-called westerly wind bursts, and quasi-stationary easterlies, which are part of the trade winds overall. Here we show that internal downwelling Rossby waves and Kelvin waves are regularly formed beneath the easterly-westerly wind convergence zone, EWCZ, which we'll use as an abbreviation. When the longitude of EWCZ is located east of 175 east, that's just to the east of the dateline. 175 east is just to the east of the dateline, or sorry, just to the west of the dateline. The Kelvin waves formed beneath the EWCZ reach the eastern Pacific boundary and determine an El Nino event, and the more the EWCZ elongates eastwards into the Central Pacific, the more the observed El Nino event is classified as severe, suggesting that the position of the EWCZ is an important factor to trigger El Nino. So this is not the trigger, but it's an important factor to trigger an El Nino. So there are a lot of these necessary but not sufficient conditions, like the recharge discharge that I have talked about elsewhere. So it's still tricky. It's just adding another grain of sand to the pile of knowledge that exists and that is incomplete. Therefore, we study zonal shifts of EWCZ and show that the EWCZ and the deep atmospheric convection displace zonally in phase with each other and with the Southern Oscillation Index, indicating that the longitude of the clash between the easterlies and westerlies determines the climate state of the Pacific and triggers the El Nino initiation. Okay, so let's just run through a few figures and read a few words from the conclusion. So we are looking here at longitude of convergence and Southern Oscillation Index. The correlation coefficient between them is minus 0.9. That's one of the highest correlations I've ever seen for any climate variables. Longitude and wind inversion point here and the Southern Oscillation here. So Southern Oscillation is the negative number here. Darwin has to be, so it's Tahiti minus Darwin. I guess Tahiti is usually high. No, Darwin minus Tahiti. So intuitively you have to think why it's negative. Longitude of the wind convergence point. So you can see that there is a remarkable correlation between them. So this goes from 1980 to 2019, which you have to be careful about because it's possible that some things changed in the 1970s and maybe some things changed in the 1990s. So there are all kinds of other ideas on regime shifts in the tropical Pacific and potentially in the global tropics and elsewhere as well. Looking here at B, so this is the time and depth plot of mean density anomaly in the region of 2 south to 2 north, so deep tropics, longitude convergence, and so -5 to +5, so that is around the wind convergence. So you take the wind convergence point and you do longitude of minus plus 5 degrees, so a 10-degree band, a box. So you are looking at the signatures of the internal waves that we mentioned before. When the thermocline moves up and down, you have downwelling and upwelling waves. So a Rossby wave that goes westward, downwelling wave will lift the thermocline as it goes west, and upwelling wave, Kelvin wave, which goes east along the equator, will lift the thermocline eastward as it moves east. Okay, so SOI, EWCZ, and internal wave generation, and this is the time z plot of mean temperature anomaly in the region of 2 south, 2 north, and 10 degrees around the convergence, wind convergence. So again, you see that this is the mean density anomaly, and this is the temperature anomaly. Obviously, this includes salinity as well. So you can see typically the argument is that the discharge has happened and warm waters have converged to the west, and then they will slosh to the east depending on these waves, which is what the argument is here for triggering an El Nino. And this has been a debate about whether recharge discharge is a continuous oscillatory process, so it's a stable oscillatory system, but then the irregular periodicity has to be explained. But if you have a triggering mechanism, that means they are episodes which are triggered by wind convergence and waves mattering rather than just a sustained oscillation of a stable system. Does this explain the irregularities of El Niños? They don't occur every year or every other year. They don't even occur at a fixed period, so you have to explain that part as well. And in this case, depending on the winds and the waves generated, the convergence point can vary, which is related to the southern oscillation, and that's the main argument. So we are looking here at average winds east and west of the convergence. So zonal winds average east-west, so red and green line of the wind convergence. So you have easterlies and westerlies, so you have to just be clear these are negative numbers here, so they are easterlies. When you have positive zonal wind, that those are westerlies. So you can see that it's dominated by the different time scales in the two. The easterlies are part of the trade winds that are penetrating more eastward or not, and westerlies are happening in the western part of the tropical Pacific, and they are so-called westerly wind bursts are explained with various mechanisms, high latitude, local cyclones, and so on and so forth. So there are still unknowns, but at least this tells you why there may be irregularities in the convergence zone and the waves associated with them. So this is the difference in zonal wind average east and west of the dateline. So we are going here from again 1980 to 2020, 2019 out to 2020 or so, and this is the difference. This is the winds themselves, and this is the difference between the easterlies and westerlies. So you can see that is so ux easterly minus ux westerly in meter per second, and that begins to show the character that we looked at in terms of potential relation to southern oscillation index, leading to the arguments about the initiation maybe of the El Nino. Okay, so we are now looking at the Haufmuller diagram along the longitude. So daily Kelvin wave amplitude, and superimposed on the image the red line representing the longitude of the wind convergence computed from the daily wind data. On the right vertical axis, points represent El Nino events classified with the same color legend that we looked at before, so which is here. So these were the various classifications of El Niños which you can look up in the paper. It doesn't matter so much because it's been argued whether there are multiple flavors of El Nino and whether the mechanisms for them are different, or they are all just different expressions with the same underlying mechanisms. So this would seem to indicate that they are all related to this easterly westerly wind convergence zone for initiation of El Nino. So we are going again from 1994 now to 2020 or so, and there are the strong El Ninos, 97, 98, 15, 16, with the smaller warming in 14. 18 was a mild El Nino as well, and you have the convergence zone. Just to remind you, there was a similar paper on convergence zone of the cold tongue and the warm pool by Joel Picot and others in the 1990s, and they had similar argument, but this was more about geostrophic wind convergence into the warm fresh waters on the west and cold salty waters on the east, and how they move together. But that's more of a mechanistic explanation of what happens and not necessarily an indication of initiation of El Nino. So this is new addition of information in that sense. So here we are looking at longitude of maximum wind vertical advection point and southern oscillation index correlation coefficient is at minus 0.6, which is statistically significant with an explained variance of around under 40%. So longitude of maximum wind vertical advection is shown in blue, and southern oscillation is shown again in red. So this is the time longitude plot again of surface vertical wind component. So basically it tells you something about convergence of the winds and rising motions, which corresponds to convection as well. Okay, so SOI, atmospheric convection, and easterly westerly convergence zone. Just that there is a huge consistency between the winds converging, vertical motion in the atmosphere corresponding to convection, and that moving with the eastward propagation or eastward spilling of the warm waters, just arguing that El Nino triggering or is indeed very strongly related to this easterly westerly wind convergence and the waves associated with them. The waves are needed basically to bring the ocean in a position to respond to the winds, because the Bjerknes feedback, where you have winds reducing the upwelling or some Kelvin wave generated in the west, pushing the thermocline down and creating warm waters, changing the east-west surface temperature gradient, creating a wind response and a feedback to the upwelling in the thermocline and the warming. So I have podcasts on Bjerknes feedback elsewhere that you can look up. Okay, so what's the conclusion? There is a long discussion which I won't go into. In this paper, we have discussed El Nino initiation in relation to westerly wind forcing and internal wave generation from a slightly different perspective to that commonly adopted. Specifically, we have seen that westerly wind events are Rossby wave and Kelvin wave generators in the sense that their encounter with the nearly stationary trade winds determines the convergence and therefore the conditions necessary to excite the waves. Okay, so that's where the triggering mechanism comes in terms of exciting waves. However, only when the easterlies and westerlies convergence occurs east of 175 east is an El Nino event effectively initiated. So this explains why many times you may have westerly wind bursts to the west of the dateline, but you don't get an El Nino. We have explained this phenomenon in terms of mutual annihilation of Kelvin waves and Rossby waves propagating over a flat interface, and deviations towards the poles of Rossby waves propagating over sloping interface, which consequently east of 175 east, where the thermocline starts sloping, exit from the equatorial belt and stop interacting with equatorial Kelvin waves. So some details. There are related papers by Alan Clark arguing that the so-called recharge-discharge may be just this interaction of Rossby waves and their poleward dispersion and so on. So these are all related ideas, but a different perspective, as the authors admit. In this context, we have emphasized the importance of the position of the easterlies and westerlies convergence and shown that it's correlated with the SOI. This suggests that westerly wind events are part of the tropical Pacific climate system, and indeed we found that lateral shifts of the atmospheric convection, changes in the large-scale zonal sea level pressure gradient, zonal displacements of the easterlies westerlies convergence zone take place in phase. Okay, maybe I didn't emphasize that properly, so let me read it again. This suggests that westerly wind events are part of the tropical climate system, and indeed, we found that the lateral shifts of the atmospheric convection, changes in the large-scale zonal sea level pressure gradient, zonal displacements of the easterlies-westerlies convergence zone take place in phase. So there is an and needed, so my emphasis was wrong because they missed an and over there. These results, along with the fact that zonal displacements of the Western Pacific occurs, the warm pool, occurs in phase with the SOI, beside defining a synthetic parameter that describes favorable conditions for El Nino onset, i.e. eastward extension of the easterlies and westerlies wind convergence, provide a description of the tropical Pacific climate system in which El Nino is the logical consequence. Indeed, the competition between westerly wind events and easterlies determine zonal shifts of the warm pool, triggering the position of the deep atmospheric convection. However, zonal displacement of the deep convection determines the changes in the tropical Pacific pressure system, and consequently determine the changes in the intensity of westerly wind events and zonal displacements of the easterlies-westerlies convergence zone. When the position of the easterlies-westerlies convergence reaches 175° east, the thermocline starts sloping. Kelvin waves and Rossby waves are formed over the sloping thermocline, and an El Nino event is recorded. So still atmosphere-ocean interactions, but waves and wind convergences along with atmospheric convection are invoked to have a feedback to the westerly wind bursts and the thermocline and sea surface temperatures, etc. I won't read all of it, but as a final remark, under the influence of global greenhouse warming, the mean climate of the Pacific region will undergo significant changes. Specifically, projections involve weakening of the trade winds, changes in the thermocline depth, decrease of the zonal sea surface temperature gradients, and more intense and frequent El Nino episodes. This is you have to be careful because these conclusions are cited here from one paper, but there are many other conclusions as well about what will happen in the future. Especially worrisome because we haven't explained what has happened so far in terms of the warming and the response of the El Nino and the winds and the thermocline and so on. We believe that the results presented here offer valuable insights on assessing possible future shifts of ENSO regimes, including useful considerations related to the climate change and security nexus. It's our intention to carry out research with the aim of estimating long-term changes in the position of the easterlies and westerlies convergence zone and in the shape of the isothermal surfaces that can explain changes in the characteristics of El Nino episodes, which means the so-called eastern Pacific El Ninos or cold thing El Ninos or the canonical El Ninos, the dateline or the central Pacific El Ninos, the extreme El Ninos like 97, 98, 2015, 16, and maybe 2023, 24 as well. Okay, so not exactly new finding in climate change, but very deeply related to what the issues are for climate change in terms of natural variability, especially because the Eastern Pacific warming, slower or cooling in response to global warming determines how fast global warming actually happens, because that determines how much heat goes into the ocean and how much remains in the atmosphere from the additional forcing created by greenhouse gas increases, right? That's the warming pause we have discussed elsewhere. Okay, let me leave this here and come back to the next topic in the next podcast. See you there.